Hello, good afternoon, good morning, depending where you're joining us from. Welcome to the webinar. I'll already share my screen. I think it's fine. Yes. Can you see it, Martin?
Yes, I can see it.
Perfect. Welcome everyone to this webinar. It's good to have you joining us. It's our first webinar around our CLI and API, so we are excited to share some of the knowledge with you. Great. I see some more people joining. Just give a few seconds. And then we can get started. Maybe we can get started already with a little icebreaker. Typical to just get things started and while other people are joining us. But we always like this question, allows us to travel sometimes, share travel. So if you want to share with us in the chat, so you can find it below, where you are joining us from today, that would be nice so we can know. Where are we covering? Sweden, okay. Close. So I'm joining from Denmark, in Copenhagen. Don't know which part of Sweden you're joining from, Alex. And Martin, not too far, also in Sweden?
Yes, just across the bridge in Malmö.
In Malmö, great. And Damien from Copenhagen. Okay, very close. It's great. Okay, great. I see some sending privately here, but that's all good. I'll get started so we don't, so we get into the webinar. Before presenting, I would like just to go through some housekeeping rules. As you can see, this webinar is being recorded. So at any point, if you need to leave or you want to go back to a part and rewatch it, we will send it to you if all goes well tomorrow. And also welcome to those of you who are joining us through the recording. If you have any questions, please use the Q&A tab. It's near the chat where you just used to share where you're joining us from. We will go through those in the end of the webinar. And if you have any comments or any questions non-related to the presentation, you can use the chat. You can choose either everyone or hosts and panelists. Great. So for today, the agenda, as you might have seen in the registration page, we are going through the introduction of the CLI and the API so you can understand the basics. We will go through an overview of the functionalities and help you to see how you can get it up and running. And also, we will cover some of the practical benefits and limitations so you can have it in mind when you're integrating these tools. But yeah, without further ado, and better than me talking is to see it. So I will hand it over to Martin. Over to you, Martin. I'll stop sharing.
All right, thank you. I will see if I can take your screen. Yes, now you can see my screen. So, yes. Right, so before we dive into the CLI and API and the details there, so let me just give a little brief overview of what the Debricked tool is doing, so we can put everything into the correct context here and better understand what we're going to see later. So we have a few different steps here that we're doing when we are scanning files. So the focus here will be a little bit on scanning files for vulnerabilities, licenses, and so on. Starting from the left, what we take in from the beginning is a dependency file. So if you use JavaScript, it could typically be like a package.json file, pom.xml if you're using Maven, something like that. We can also take source code as initial input, and we can also take just any file basically that you have in your repository or in your project as a first input. And what we're doing with these files then is that we're doing some local resolution. And local here means that we're doing the resolution either on your computer, if you're using the CLI, for example, in a terminal or something like that, or we're doing it locally in the CI/CD. That doesn't necessarily mean that it is local for you, but it will be in the CI/CD workers. It is nothing that we have direct access to typically. When we have done the local resolution, the dependency files will become log files. In many cases, they will be log files already, so we don't have to do this resolution for you. So this is maybe done already in building your project. The source code will be turned into a call graph, and the files will be turned into file fingerprints. We are fingerprinting and hashing all the files that you have. So I can also now already mention that the file fingerprints is an enterprise tier only functionality, just so you don't get upset if you're on the free tier or something and you don't get the file fingerprinting to work. But I want to show it anyway because it provides some really nice features. When we have these files, then it is time to upload them to do the remote scanning. And this is when the files are uploaded to the Debricked servers. So it's important here to note that we are never uploading the files themselves that you have, like these files, source code files or other types of files that you have in your projects. We are only uploading the file fingerprints or the call graphs or the log files. So this is what is uploaded to us. We will scan these files, and then the output of this will be vulnerabilities that we can find, licenses that we can find for your dependencies, and dependency health of the dependencies that we find. And also in some cases, we also provide the automation results if you're using automations in our service. So there are several different tools that you can use in order to accomplish these different steps. The tool that maybe most are familiar with that have used Debricked in a basic setting would be the user interface. I will show parts of the user interface today, but there will not be a focus on the user interface and how to use it. But if you have used it before, it's all good. It will be easy to follow along. If you have not used the interface before, it's okay. You will still be able to follow along, so don't worry about it. But the focus for today will be the CLI and the API. So just to put everything into the context here when we are looking at the CLI and the API. So what we have here on the top is the source code manager. So we separate a little bit here GitHub and other source code manager systems because we have a specific GitHub app that is possible to use. But I think it is preferable to use the CI/CD tool, whether you use GitHub or whether you use something else, to have this directly in the CI/CD without if you use GitHub using the GitHub app. The CI/CD tool will in turn, doesn't matter if it is GitHub or something else, the CI/CD tool will in turn either use our provided Docker image and download that to the CI/CD, or it will directly download the CLI. And both these, the Docker image and the CLI, will be calling the API endpoints, which in turn will be calling Debricked. Now, kind of the focus today will be to look at the CLI and look at the API. So in that sense, we'll be typically looking at the manual integrations that you can make. And with manual integrations, you can directly use the Docker image, you can directly use the CLI, or you can directly use the API endpoints, which in turn will call the Debricked servers. So this is what we're going to kind of focus on today. So I said I'm not going to focus very much on the CI/CD maybe, but let's just see how this can look like in the CI/CD. So here is quite general syntax. The syntax is the GitHub Actions syntax, but it's quite general what is happening, so you can translate this to any other CI/CD if you want. But here is an example where you're using the CLI together with the Debricked Docker image. So in the CI/CD here, you will define the Docker image that you're going to download. So this specific Docker image, there are several to choose from, but this specific one we have created such that it will be very high probability include all the possible tools that you are going to need in order to perform the resolution. And it will, of course, also include the CLI. So what you're doing then is that you're downloading the Docker image, you're checking out the repository, and then you're running just Debricked scan. And Debricked scan is then the CLI command that you are running, and the CLI is here built into the Docker image. The alternative here would be to not use our provided Docker image, but to use your own Docker image. If you have your own environment that you can have in a Docker image, you can use this Docker image yourself, and then you use that image in your CI/CD. You check out repository. Here you install explicitly the CI or the CLI inside this Docker image, and then you run the Debricked scan, which is the CLI command that you're going to use. So as you can see, if you are using Debricked in your CI/CD, you are already using the CLI, and the CLI in turn will be using the API. So as I said, this was the GitHub specific workflow that we have. We can, if you go to the documentation, and if you go to integrations in our documentation, you can see if you're using another CI/CD tool, you can see here exactly how you're going to configure this in order to make it work for specifically your CI/CD tool. But I will not go into those details here. So what we're going to focus on here is the CLI. So if you go to the CLI in the documentation, you will find a lot of documentation regarding the CLI. So basically all you need, you can find here. I'm not going to go through it, obviously, because maybe you're listening to this because you do not want to read the documentation in detail and maybe see some demonstration instead. So you can see how to get started. You can see how you authenticate with the CLI, how you install the CLI, and so on, where to download the CLI and so on. I'm going to skip some of those basic steps. So instead, what I'm going to do here is I'm just going to tell you what I did, and then we can go on with the demo quite immediately after that. So the preparation steps would be to first create an access token in the user interface, so that you do under the admin tools. So in admin tools, you have account settings, and then you can create, and here you can create a new refresh token, as they are called. So it will be an access token. And then if you want to use the CLIs, we're going to start with the CLI. If you want to use the CLI, what you can do is that you can provide this access token every time you run a command, but it is also quite convenient to just export this token to your environment. So this is also something that I have done already. So we're not going to do it explicitly here. And then we're going to install the CLI. And you can see in the documentation exactly how you download the latest version. So in this case, I just downloaded the CLI, and then we have it. So with that as a background, let us start looking at some of the uses for the CLI. So here you can see that I'm in a demo folder. I'm going to have 4 different things here. So I have the Debricked CLI. So this is what I downloaded, the CLI, and then I will have 3 different repositories that I'm going to use for demonstration. So let us start by just looking at what can we do with the CLI here. So if you just type Debricked, you start the program, and you will see the available commands that you have. I will not do exactly all the commands here, but I will actually do most of them. The most important command that you do in the CLI is obviously the scan command. But then there are a few other commands also that are quite convenient. But you can already now, we can just clarify that both resolve that we're going to see, the fingerprint and the call graph, can be done directly with the scan command by using options to the scan command. But we're going to see parts of this also separately and explicitly. So let us start to go to the Jew shop, which is one repository that we have. We're going to use the first command that we're going to try out is the one that is called files. So we're going to see what files are going to be uploaded to Debricked if I make a scan. So let's see, Debricked files, and then there is a command called find. So here you can see what the files that will be uploaded that we have identified is the package.json that is in the front end. And then there is also a package.json in the root folder. As you remember maybe from before, what the first thing we want to do is to resolve these files into lock files. And then we have a command for that, Debricked resolve. So if we run resolve on this, we will see that we have these 2 files have been identified. We're resolving them, and now if we again run files find, we will see that we have now found some more files. We found in the front end the package.json, but also the corresponding, now we have the yarn log file. And similar for the package.json here, we also have the yarn log file. So now we are ready to scan the files. And as I said before, you don't really have to do resolve before you scan. If it hasn't been resolved before, it will be resolved as part of the scan command. So before we run scan, let us look at the help here and see what it says. I will not go through the details here in all the options that you have, but there are a few options that we can look at. So one is, for example, the call graph. If you don't want to make the call graph explicitly, so we will see an example of this later, but you can do this as part of the scan command. One interesting part here is the commit option that you have, or -C option. So if you don't provide the commit here, we will take the latest commit hash that we find, and then we will use that as the commit string. But you can use your own commit string if you want to as well. So you can just define any commit string, and we will use that instead. And that can be quite convenient in case where you want to tag a specific version of your repository. For example, release 1.0 or release 1.1 or some beta release or something like that. So you can do this with the commit string. Similarly, if you scroll down, we also have the repository string. So we will take the default repository that we find from the Git information if we don't get anything in repository here. Otherwise, you can define your own repository string here. So you can rename your repository as you will see it in the results and in the user interface later if you want to do that. So with that in mind, we are going to scan this, and let's change the commit to something called release 1.0. Let's call it that. And we will keep our repository name as it is. So now we're scanning, we're seeing what is being uploaded to our service. So both the package.json files and the yarn.log files will be uploaded to our service. They have been scanned, and now the output of the scan, as you will see, we will find, in this case, 13 vulnerabilities. We have the results of the automation. So if you have configured some automation rules in the service, this is the result of this automation. So here is one rule that we have said, that if a dependency contains a vulnerability which has not been marked as unaffected, where CVSS is at least high, then send a pipeline warning. And then we have a few different vulnerabilities here that is matching this specific automation. So let us go to the user interface now, and we will see what this looks like. So let's refresh this one. So we can see that we have a new scan for DuShop. We have, let's see, previously we had a few releases. Now we scanned release number 1.0. If we look at, we can go in here and we can look at the results. So you have the CVE, you have the severity score, you have dependencies, and you also have some review status that you have. And the review status will be tied to the repository. So here you will have the same review status as you had in the previous scans. We could also see that we had the policies here. So there was some vulnerabilities here that matched the policies. So if we go to the policies that we had for UShops, we go to automate. We see here that we have the specific policy here that was triggered in the scan. So if the CVSS is at least high, so this is the automation policy that we matched. So pretty straightforward how we can do this. Just scanning a repository. We can do something a little bit more interesting maybe. So let us go to the reachability demo. So in this case, what do we have? We have a Java project, we have a POM XML file, and then we also have a log file already. So here we have already resolved the POM XML to a log file. So if we scan this one, and we're going to do this in two different versions. So we're going to scan, let's see, and then we can rename the repo to something that makes kind of sense. So CG for call graph, because this is what we're going to look at here. And we don't have a call graph right now. So the commit, let us call it no call graph. And then we scan this. And we see that we're uploading the POM XML file, we're uploading the log file as well. So let us wait for this a little bit. It just take a few seconds only to finish. So now it is finished. We have similar output as before, the results from the automations. And now let us do the same thing again, but this commit we're going to call with call graph, and then we're going to add call graph information. So call graph here means that Debricked is going to build a call graph. So here you can see that we're building the project. We are building or generating a call graph for this project. When the call graph has finished generating, should take a few seconds. Here it is done. Now we're uploading both the call graph and the log file and the POM XML file. So different from before, because now we have a call graph, so we're uploading the call graph as well. So let us immediately go here to the repositories page. Let's refresh. Now we have this new repository that we named CG for call graph. If we go to this, we look at the commits. So the one with no call graph is finished scanning. We found 79 vulnerabilities. The one with a call graph has not finished scanning yet. It has already found the 79 vulnerabilities, but what is happening now is that this is analyzing the call graph in order to see if the vulnerabilities are reachable in your program. So just to compare these two, for no call graph, it looks exactly like we are expecting. We have the CVE, we have the CVSS score, and so on. If we look at the one where we're also analyzing the call graph, you will see that we have another column here in the results. And this column will tell you if we can find a reachable path in your program to the actual vulnerability. And since this is still scanning, it just gives the result that it has so far. So it's found 2 of them, several unknown. If we refresh this one, we have found several more. So this will take a little while. If we go to, let's say we go to the first one here, and we look at this in a little bit more detail, we can see what repository we are in. We can see where we have found the vulnerability, but specifically here, we have a button for reachability analysis. And if we look at the reachability analysis, we can see exactly how your program is calling the vulnerable function. So from in a specific file, we have in your code some line that defines, in this case, it's just the main, and then there will be a path to the vulnerable function here. So this is what we have identified as the exact vulnerable function for this vulnerability. And if you want to expand this, you can see exactly the call path from the main of the function all the way down to the vulnerable functionality, which can be quite useful to look at. But I think particularly useful here would be to look at the reachable path, because if something has been found, if we have a reachable path, it means that this should probably be highly prioritized to fix. Here we have found everything. If we go to this one, here we have a few where we have not found a reachable path. So typically when you do triage for these vulnerabilities, you will typically say that, well, it is not so urgent to fix this vulnerability because it doesn't seem that it is possible to reach the vulnerable functionality inside your code anyway. So why should we rush to fix it where we instead could fix the ones where we have a vulnerable path? So let's go back to this. We can see the scan has finished. If we look what we have inside this repository now, so what has been created now, which we didn't have before, is this call graph file. So basically what this means, if we have this call graph file, it will be submitted. If we don't have the call graph file, then it will not be submitted. So we will scan with or without call graph. We can, if we want, if we remove this file, we can do just call graph, the call graph command in order to just build this call graph explicitly. And then you don't have to do it in the scan command, but if you see a point in separating this into 2 steps, then you can do it. Otherwise, you can just do it as part of the scan command. But now you see, again, we have the call graph here. So that was reachability. Let's also look at the fingerprint. So what we have here in this project is, again, a Java project. We have the POM XML file. This has already been resolved to the Debricked log file. So here we're going to do basically the same thing as we did before. We're going to run the CLI to scan. And we're going to scan, and we're going to call the repo something that makes sense in our specific setting here. So let's call it FP as in fingerprint. And then we don't have any fingerprints yet. So we're going to call it no fingerprint in our commit. So we are scanning this, uploading the POM file and the log file. In this case, let us wait just a few seconds for this scan to finish. So here you see that the scan has finished. What we can do now is that we can do the same thing. We call the commit FP, but we can also add the fingerprint command. But just for the sake of the example, let's just run the fingerprint command like this, and then we do the fingerprint explicitly. We look at what we have in the file. So now we have added this file, the debricked.fingerprints.txt. So now we can do basically the same thing. Since we have this file, it will upload the fingerprints. So we can scan this. We call the commit now FP because now we're using fingerprints. You see that we're uploading also the fingerprints file because we can find the fingerprints file in this directory here. Let us go to the results. Let's hope we have an FP repo now. Yes, we have a fingerprint repo. It has found 2 vulnerabilities. Let's go into this, to the commits. So 2 vulnerabilities, and now we have reached so far that we have also found 3 vulnerabilities using the fingerprints. And this has also finished scanning now. So both has finished scanning. If we're looking at the no fingerprint, what we find are 2 vulnerabilities that are in a library called Quartz. If we look at this, how did we find this? Well, we found it through the maven.debricked.log file. So that makes sense because that is the file we uploaded. But when we did the fingerprints, we uploaded one more file. We also uploaded a fingerprint file. And here we see we have one more vulnerability. In this case, we have this vulnerability here, which was not found in the example where we had no fingerprinting. And here we can see that here we find this vulnerability specifically in a certain jar file that we have in the project. So this jar file was apparently not defined, or this library was apparently not defined in the POM XML file. It was just added to the project explicitly, and then it was used by some developer. So by using fingerprinting, we are able to also find these types of vulnerabilities, which is very powerful in many situations if you're not absolutely certain that everything has been defined in your POM XML file in this case. So I think that was basically it for the CLI that I wanted to show. Yes, so let us continue with the API. The API is in some sense a little bit more tricky to showcase because the API is typically used programmatically with a lot of code and so on, but we're not going to do it in that way. So let us start in the documentation. We have the Debricked API, so have information about the API, how you authenticate with the API, and other information. And here, if you go to this link here, the API reference, you will see all the endpoints that we provide for the API. So here you can use all the API calls directly, and here you get information regarding all the API calls that you can make. And this is quite convenient if you want to have something that is tailor-made. for your specific use case. And maybe you're not really happy with how we are presenting things. You want to do things yourself. So I'm going to show this using this API documentation website, not only because it's like easy to show, but also because then we can see how we can take advantage of the information that we find here in order to understand better exactly how the API is going to work. So the first thing that you need to do is to authenticate yourself. So you need to associate the usage of the API here with your account that you have. So in this case, we're going to use the a JSON Web Token in order to authenticate. I'm going to just, so here is a command. This is, you can also find in the documentation exactly how to do this. So use the login refresh command. You send in the refresh token, which is the one you generate in the user interface, and you will get back a JSON Web Token here. Let's copy the JSON Web Token like this. And then we try to get access. And here it says how you can do it. So here it says an example where you send your username and password, but you can also do this with a token. So you can choose which you like here. So we submit the web token here. Now we are authorized to use it with the token that we have now generated. So let us just look at a few examples of what we can do here. So we saw with the CLI how we could scan different files. So let us see if we can do the same thing with the API. And this will be the first two endpoints here that we're going to use. We take the first endpoint and we look at this. We can try it out. And trying it out means that you can just immediately try to use the API and it will do a lot of things for you. You will always have to use 1.0 for the version string. So what we're going to do first now is to upload a file. So now we're going to upload a lock file that we want to scan. But this endpoint only uploads the files. It doesn't start the scans. And it says also here, when you're finished, then call these endpoints with your CI upload ID. And this is something that we will get returned to us here. So what file do we want to scan? Let's see, we can take the same thing as before, the fingerprint demo, the lock file in the fingerprint demo. Some things we can choose here, but we can do the same thing as we did in the CLI. So repository name, let's call it API, so we can easily identify it. The commit name, just call it R1, as in release 1 maybe. Some other things you can choose. The first file you want to upload here, you need to uncheck this box here, so you don't send any upload ID. If you don't know that you need to do this, the response will tell you that you need to do it anyway. So it's probably straightforward to use anyway. So let us execute this. And what you can see here, what is quite convenient, is that you can see exactly what command was sent in the API here. So this was a post which sent a few headers and it sent some data. The file was sent here, and the syntax here for sending a file, this is specific to curl, of course. So if you're using some programming language to do that, you need to check how to send files using that language instead. You see the request URL, and then you see exactly the response body, what it will look like. And the response body will have the upload ID, which we're going to copy because we're going to need it in the next step. But if you want to send more files here to scan, you saw in the CLI, we sent several files in order to scan. If you want to send more files, you tie this together in one kind of one batch, but you're sending them in sequence when you tie them together with this upload ID. So if you want to start a scan now, we take the next endpoint, call this endpoint to conclude files upload and queue files for scan. Okay, that sounds good. We click on try it out, 1.0. The upload ID, because we need to know what scan are we going to start. So we're going to start a scan that has this upload ID. Nothing more here to change. We can execute this. And we see exactly what the command looked like. Again, we see the response. You get the repository ID, the commit ID, if this is something that you need. Here, let us go back to the user interface. We refresh, and here we have the API. And you see that again, we find the same two vulnerabilities that we did before. We did not submit any fingerprint files. We didn't find the additional vulnerability that we found with the fingerprint, but we found the other two that we found before also, the ones in Quartz. So basically same thing, but now we use the API instead. So that is just that is one use case if you want to upload the files using the API. Another use case that could be interesting is, if we scroll down a little bit, is the request logging. So here we are logging all the requests that are made to Debricked. And if you want to check this log, or if you want to make a small script that is analyzing the log, what has happened in your organization and who has done what, then you can use this API endpoint. So the second one here is called get events. Don't have to provide anything else than just the version string. We execute this, and then you see the JSON that is returned here is an event ID and then an event name. And the event name hints on what is the actual event. So event created pull request, toggle enforce comment setting. Scroll down, we can see like deleted repository, started a manual scan, changed the use case, logged in. So if, for example, let's say we want to see who has logged in to our organization account during the last, I don't know, hours, weeks, months, then it has event ID 17. Okay, so then we can get the request logs. If we go to the request logs, what we need to provide here is the event ID. So let's say 17 here, because this is who has been logged in. Then there are several different data that we can filter by if you want to do that, but let's just get everything back. We need to submit which page number, because this will be paginated, and how many in each page that you want to have. And again, the version is 1.0. We execute this, and what we get back down here, the response body, you have JSON formatted and just who has logged in, when the login took place, from what IP address the logged in was, and so on, that you can find in the request log. So that is probably just your imagination that stops you, that well, restricts you from what you can do with the API in this case. So I'm going to show you one other use case, but I'm not going to sit here and fill in the API because maybe it's boring to look at after a while. But let us show this only in the form of a picture. So let's say that you want to provide your own dashboard where you have information about vulnerabilities, maybe repositories, commits, and so on, similar to the dashboards that we are providing you with. So there are a few different endpoints here that could be interesting. So we have one called Get Repositories that will give you an overview of the latest commit for each of the repository, the total number of vulnerability statuses, and the commit IDs. So this is not much different from, if we go back to what we have here, if we click on repositories, this is basically the information that you have here. And this is how we are presenting the information to you in our interface. If you want to have your own interface, well, then you can just use the data that you get back and create your own interface for this. You also get the repository ID back, and that repository ID back that you get back, you can use to get information about vulnerabilities for a specific repository, which is basically the same thing as if we are clicking on a repository here. So let's say we are clicking on this one. So the information that you see here is other direction, is more or less the information that you get when you're calling this API endpoint. So you can tailor this in any way you want if you're interested in that. If you want this for a specific commit, you can do the endpoints call get commits for the repository ID. Again, you can click here and you can see the different commits that we have. So basically the same information that you see here is also the information that will be returned from get commits. And similar for get vulnerabilities for a specific commit, you will get all the vulnerability information for the commit. So if you click on this one, this is how we are going to show this, but you can show this in any other way that you want. So I'm going to wrap this up. Coming back to the picture that we saw in the beginning for the overview of the Debricked and the capabilities that we have and what you can do. So let us summarize what we have seen. We've seen that we do local resolution, but we've also seen that you need to use the CLI to do local resolution. Of course, you cannot use the API to do local resolution in this case, because the API is calling endpoints on our side. So all the local resolution you have to do either yourself or with the CLI. The remote scanning you can do, or initiate the remote scanning, you can do both with the CLI and the API. So it doesn't matter which one you use there. You probably have some more features to use if you're using the API though. And as for the results, when you look at the vulnerabilities, licenses, and dependency health, this is shown both in the UI, but this can also be returned to you as data in the API. The automation results that you saw that we returned in the CLI can also be returned in the API, or they can be fetched, the automation results, in the API. And that is, of course, how the CLI works, by calling the API endpoints to get this information. However, you will not be able to find automation results in the UI. Instead, the UI is used to configure the automations instead and say what you want to do when something triggers. And that can, for example, trigger an email. So then you see the results in your inbox, and you can trigger a webhook. So you can see the results in, for example, Slack. You can trigger pipeline fails or pipeline warnings, which will show the results in your pipeline. Or it can also do some automatic triage in this, but it will not show the automation results in the same way as it did for the CLI and the API. Just a final thing to note here. So the call graph analysis is currently supported for Java and Go, and file fingerprinting is currently supported for Java and C#, but we have very soon also support for Python and JavaScript for file fingerprinting. And I think that wraps up what I was going to show you here regarding the CLI and the API. Do you want
Perfect.
to finalize this, Benedita?
Yes, sure. Thank you, Martin, for your presentation. I hope for everyone it was helpful. We have actually a question now, actually two, one in chat. So we can go over that in the next few minutes. And if anyone has more questions, please let us know. We know we are a bit short in time, but we can take a few extra minutes for that. So we have a question. Can you use the API for user administration for the dashboard?
Yes, there is administration endpoints as well in the API. So basically anything that you want to do, basically, maybe not everything, can be done using the API. So here under admin, you will see all the administrative endpoints that we have, and these are typically restricted to an admin user of the company. So I didn't show this before, but you can choose the scope for the token that you're going to use. If you're going to have an admin scope, if you're going to have a user scope. So if you're using the user scope, you will not have access to the administrative features. If that answers the question.
If there's any follow-up questions from this one, please let us know. And then we have another question, which is, this one was in the chat, sorry, I have to find it. For how long is the token valid?
The refresh token that you generate in the UI has infinite validity, which is quite common because it's a refresh token. But the web token that you are generating for using the API has a lifetime of 1 hour exactly. So you typically need to make sure that your program re-authenticates after 1 hour. Or if you get a request back that says that you are not authenticated, and then just re-authenticate again and do it. So that just has to be built into the program that is using the API.
Perfect, thank you. We have one more question also in the chat, which is somehow not related here, but we could answer. I have recently learned that there is currently no C++ Debricked support. Is this language support on the roadmap already? Is there some sort of...
I don't really dare to answer a roadmap specific question, because then someone might, well, there is a high probability that I might be wrong. And
yeah.
So I think, I mean, those kind of questions, I think reach out to support. Let's see what, if we go to this one, I can show you. Am I still showing my screen?
Yes, you are.
Oh, good. So if you go to help here, okay, it was already here. So you can contact support@debricked.com. For those type of questions, I think you can get a more authoritative answer than bad guess from me.
Yeah, but we can take note, Lucas, that you're interested, and we will do our best to reach out if there's a more concrete idea that we can commit to share with you. Perfect. I see there's no answers and we are no more questions, sorry. And we are at time, so I'll give a few more seconds if anyone has any more burning questions. Otherwise, we will also send, as I said in the beginning, the recording, if all goes well, tomorrow. And if you have any follow-up questions, let us know. And also, just a reminder, maybe some of you have seen this, if some are using the legacy CLI, it will stop working next week. So we really urge you to migrate to the new one. You might have seen these announcements in different places. We tried our best to share the message at one more forum here. If you have any questions, reply to the email tomorrow or reach out to our support team. And yeah, if there's any feedback from today's session, this was the first time we went into the CLI and API area. Anything you feel that we were missing, you would like to deep dive, or something we could have skipped, just let us know. We would appreciate that. And yeah, we will hope to see you another time soon. Thank you for joining and have a good afternoon. I guess most of the people was afternoon. Thank you.
Thanks for joining. Bye.
Bye.